All right, and welcome back. So today we are going to be talking about multiplying polynomials. So far we've talked about how to add and subtract them, but now we're going to be talking about how to multiply polynomials. So without further ado, let's have out our guided notes and let's begin. So to multiply monomials, we multiply the constants, then multiply variables that have the same base. That might sound a bit complicated, but let's go through an example to talk about what we mean. Let's say we want to multiply 3a squared b times 4ab to the third, or b cubed. Notice how everything inside the parentheses is getting multiplied in both aspects. So 3a squared b, all that is getting multiplied. 4ab cubed, all that is getting multiplied. And now both sets are getting multiplied together. So every single factor of this whole problem is getting multiplied. So we are allowed to use some properties of multiplication to move around some of the aspects of the problem. We can rearrange that the constants and the variables with the same bases are going to be together. Notice how we now have 3 times 4, we have a squared times a, and b times b cubed. Now we can simplify. Well, 3 times 4 is 12. A to the second times a to the first, that's a to the third, or a cubed. And b times b cubed is b to the fourth. All we did there is just understand that everything is getting multiplied together, so we can rearrange the way that we like it to help us simplify it. Great job. To multiply a polynomial by a monomial, we're going to distribute the monomial to each term within the polynomial. And again, that might sound complicated, so let's go through and talk about what we mean. Let's say we want to multiply 2x by the polynomial x squared plus 3x plus 7. Notice how inside the parentheses there is addition going on. Addition, and it could be subtraction, but we have a polynomial because we have multiple terms together. So we have to distribute this monomial. We're going to distribute the monomial 2x to each term inside the parentheses. So notice how we draw the arrows. Drawing arrows when it comes to multiplying polynomials is going to be super helpful. Please do not think you are above it. It's extremely beneficial to draw the arrows. Even I still draw the arrows and I teach this. It is extremely helpful to draw the arrows to show what you're distributing to each term. So now we have 2x times x squared plus 2x times 3x plus 2x times 7. Because again, we distributed that 2x. Now we can simplify, and we get 2x to the third plus 6x squared plus 14x. Awesome. With this in mind, please work on problems 1 through 12 on the guided notes and resume when you're ready to move forward. Remember, draw your arrows. Now, let's talk about how we multiply binomials and polynomials together. So far, we've talked about monomials, but we're going to be having a very similar process here. If we want to multiply x plus 3 times x minus 7, we are again going to be using the distribution process here. We have a binomial on the left, that means 2 terms, so x and 3, those are 2 terms, getting multiplied by another binomial, x minus 7. X is 1 term, 7 is the other. But that's separated by a subtraction sign. But it's still a binomial. We are going to be distributing the x to the x minus 7 and the 3 to the x minus 7. So notice how this x is now on the outside and this 3 is now on the outside. But we kept x minus 7 together because we're sending the x in the first set to the x minus 7, and we're sending the 3 to the x minus 7. And now we can distribute once more. So we have x times x minus 7, which turns into x times x, and x times 7. Let me draw some arrows here for you. So this x goes to here and to there. 3 goes to the x and to the negative 7. And now we can simplify. We get x squared minus 7x plus 3x minus 21, but we notice we have some like terms. So we have negative 7x plus 3x, which gives us negative 4x. So we can combine those like terms. We're soon going to be talking about what is called the foiling method, which is a separate way to go about this. And let me show you that. If I have x plus 3 times x minus 7. Instead of doing the multiple distributions, what we can use is called the FOIL method. FOIL, F-O-I-L. What it stands for is first, the O is outside. This is very tough to draw, writing vertically. The I is inside. My spatial recognition is completely off. And then the L is last. So what that means is we're going to multiply first the x times the x, the numbers on the outside, or the terms on the outside, so that's x and negative 7, the terms on the inside, the 3 and the x, and whatever is last, the 3 and the negative 7. When we do that, we end up with x times x, which is x squared. Now in green, x times negative 7, which is negative 7x. In blue, 3 times x, which is 3x. And now in purple, 3 times negative 7, which is negative 21. Notice again, we have these like terms. So we end up with x squared minus 4x minus 21. And if you notice, that's the same answer that we have over on the left-hand side. X squared minus 4x minus 21. So the foiling method, and you'll commonly hear FOIL, 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 is just another way to show this multiplication. Instead of doing this elongated method on the left-hand side, we can use the foiling method on the right-hand side. And I really hope you jotted that down, because it's going to be a very beneficial aspect of multiplying polynomials. You send one term in the first polynomial to each term in the second, and then you send the second term to each term, and you keep on going within that process. Sometimes you're going to be multiplying polynomials that have 3 terms in each of them, and we can use this understanding of the foiling method by sending each term on the left set to every term on the right set, and we keep using that process over and over. So in here, if we're multiplying x plus 5 times x squared plus 3x plus 4, essentially what we are going to be doing is we're going to be taking this x, sending it to all 3, and then taking the 5 and sending it to all 3. That's essentially what we are going to be doing. And we're going to rewrite it as we go and then simplify. But let's show the elongated method to do this. So again, we're going to be distributing the x to the polynomial on the right, and again the 5, the polynomial on the right-hand side. Notice how we did that with our color for arrows. Let me show a little bit of a connection there for you. And then again, we're going to distribute again. This is exactly what we would have been doing before. We simplify and combined our like terms, and we now end up in standard form with x to the third plus x squared plus 19x plus 20. Again, we can use the idea of that foiling method, and we can expand our aspect and our application of it into bigger polynomials. We're taking each term in the first polynomial and multiplying it with each term in the second. And we repeat that process until we've used all of the terms in our first polynomial. Fantastic job with this, kiddos. You're working really hard and it's showing. Super proud of yourselves. You're doing very, very well. keep working hard and keep making yourself proud. With that, please work on problems 13 through 20 on the guided notes. Please let me know if you have any questions, and I'll talk to you soon.